Hello, ladies and gentlemen. So today we're going to be looking at intersections on or inside a circle. So one of the things that we're going to have to look at is this topic right here, secants. So in the past we talked about secant and secant line. This is a line. This would be a segment. So we're getting really specific here. So just a real quick example on a circle, you can have a secant anywhere. And remember, it has to have exactly 2 points. So it intersects a circle in exactly 2 points. And this is a line segment. So we can draw a secant wherever we'd like. I'm going to call this one AB. Notice it stops versus a secant line. And we're getting really specific here, and we have to kind of keep these in mind. Remember, this one has 2 arrows, and it keeps going beyond the circle. We're going to call this one D and C. So AB is a secant. CD or DC is a line, a secant line. So keep these in mind. Intersections on or inside a circle, we have 2 secants that intersect. And they create angles. I want you to notice the formula. We have the front arc and the back arc. So we have 2 arcs that we're going to be looking at. We're going to be adding them and then dividing them by 2. So we're really going to have to make sure we know which angle we're talking about. So for example, if we talk about angle number 1, the front arc and the back arc. So AB and DC. Those are the arcs we're going to be looking at for angle 1. So I know, and I can write this generalization right here, the measure of angle 1 is arc AB plus arc DC divided by 2. Can I change these to be arc BA and arc CD? Of course I can. I can switch them around. Not to mention, can I make this arc DC go in the front of this addition? Yes, I can, because remember, addition is commutative. I can move them around. So that's not a big importance because we are adding. The next part would be angle 2, because we got all these different angles. So angle 2 right here is going to look at the front arc and the back arc for that one. So we're looking at this arc over here and this arc over here. So we're going to have 2 different situations happening in this kind of a problem. So we have the measure of angle 2 being arc BC, and we're saying the front. So in front is BC, and the back arc would be AD. So we have BC plus AD, and then that's going to be divided by 2. Again, these are general formulas. Do they have to be angle 1 and 2? No, they don't. This is just in general. So we're going to go ahead and look at some specific examples. Okay, so the examples we're going to be looking at. We have this one looking for the measure of angle 1. So we're going to use our highlighter to color code this stuff. So we have angle 1 right here. And we need the front and the back. So we're going to need this guy and this arc. So we're going to need BC and AD. So we're going to have to make sure we put those into our general formula. So we know that the measure of angle 1 is the two arcs added together. So AD plus BC divided by 2. Remember, keep writing your general formulas. On an AP exam, this would be partial credit. So even if you get the whole thing wrong, this would be counted as correct, and you would get 1 point just for having that. I know you're like, oh my God, it's just 1 point. But hey, all the points here and there add up. So make sure you write this down. Some credit is better than no credit. So I don't know the measure of angle 1. I know AD is 70 plus BC is 40, and you're going to divide that by 2. So the measure of angle 1 is 70 plus 40, which is 110, divided by 2, and the measure of angle 1 is 55 degrees. That's 1. So I already know my measure of angle 1 is 55 degrees. This one, we're looking for 2 different angles. We're looking for 2 of them. So let's take a look. The measure of angle 1 is the first one that we're looking for. So the measure of angle 1 is right here. And we're looking for the arcs in front and behind. So in front and behind. Angle 2 is right here. Do we know the angles in front or behind? No, we do not. So we're going to start with what we do know. We do know the arcs that belong to angle 1. So let's start there. Let's start with something we do know. So we're going to start with the angle 1. Measure of angle 1 is the arc GH plus FI. Arc FI. And then that's going to be divided by 2. So the measure of angle 1 is GH was 131 plus 33 divided by 2. You go ahead and knock this out and we'll check our answer. All right there. So we should have gotten 82 degrees. So I know this angle right here is 82 degrees. I have a special relationship going on here. Do you see it? Do you see it? These two angles are a linear pair. So they make a 180 degree relationship. And my pen is dead. I need to throw that one away. So this right here is 180 degrees. So I know that angle 1 plus angle 2 should equal 180 degrees. Again, because they are supplementary. They are a linear pair. So I know angle 1 is 82 degrees. I don't know angle 2. And I do know that they're supposed to add to 180 degrees. So you work that out. Let's see what you get. And you should have gotten 98 degrees when you subtracted. Remember, you subtract 82 from both sides. You are solving this equation. And some of you like to draw a little wall there, so that's fine. Moving on to the next example. Ta-da! Now we're working backwards. We're looking for an arc. We have the angle, but we don't have it. We're missing an arc. So we're actually going to be working backwards. The setup is the same. Let's see. You set it up. Let's see what you got. There you go. There's the setup. Don't forget, highlight if you must. I like to highlight because it helps me keep track of focus. So this 95 belongs to this 145 and this X over here. Here's my general formula. Here's everything substituted in that I do know. How do I get rid of this denominator again? The denominator is 2, so I multiply by a whole number 2. I go from there. So these 2 multiply out to a 1. So I don't have to keep track of that. I'm left with the numerator. And then 95 times 2 is 190. I subtract the 145. Make sure, again, make sure you're subtracting from both sides. So this 190 minus this 145 actually becomes a lovely 45 degrees. So that's what my x is equal to. And now we have a plot twist. This guy, set it up and solve. Let's see what you got. Don't forget to highlight. I know doubt is created when you're sitting there and you're like, oh my God, I don't know if I set this up right. So there's the setup, double check it and keep. Another spot check, make sure you got x is equal to 53. If you did not, check out the work, cross check it with yours. I know you can find the mistake. It's usually really simple. Sometimes it's multiplication or even the subtraction. Just double check it. And then now we're going to solve for number 2 because that's what one of our questions is. And you should get that angle 2 is 133 degrees. Don't forget that this is a linear pair right here. You could have solved for this first and then gone to this. It's totally up to you. But I went ahead and I solved for the x first. And then the easy one, which is the 180 degrees, the supplementary. So that's it. These are angles created by secant segments. And have fun!